Okay, so this hopefully last video, I hope I can fit this into the last video. We're going to be talking about Taylor polynomials and then Lagrange error. Lagrange error, by the way, is a very kind of hard concept to understand. So if you don't understand it from this video, I'm sorry, I'm not very good at explaining this, and I think you could probably find someplace online. But first thing we're talking about is the Taylor polynomial. So knowing the Taylor series, the Taylor polynomial is basically it's a polynomial where instead of ending with a dot, a plus dot, a dot, as we did in the past to kind of explain, oh, this is gonna go on the same pattern forever. The Taylor polynomial is just basically just a chunk of this, and it's gonna stop. There's not gonna be a plus dot, a dot. And so, for example, let's say we have right here, you want to find a Taylor polynomial for sine of x centered at x equals 0, and we want to find t5. So this is the notation. It sometimes also be t5 of x. Taylor polynomial, and you want the highest power to be 5. That does not mean you're going to do 5 terms. It means that the highest power for that x to the n on top of the Taylor series is going to be 5. So as we know, the sine of x1 is going to look like 1 minus x to the third over 3 factorial plus x to the fifth over 5 factorial minus, wait, actually we can stop because we just wanted to go until the top power was, the maximum power was the fifth, and we did that right here. So that means that this right here equals t sub 5. This right here is the Taylor polynomial. Now, why on earth would you want this? Well, you can use this to approximate different values. So, for example, if you want to approximate what is sine of, what is sine of 2? Well, all you'd have to do then, because this is basically just a section of it, because technically this would go on forever, and if you went on forever and then plugged in, because remember that this equals, with this dot dot dot, this right here covering this equals sine of x. Equals sine of x, covering that. But because there is no dot 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 there, this doesn't exactly equal sine of x, but it's close to sine of x. And the more you go, the more specifically, the more accurate it'll be to sine of x. However, at this point, it's just asking for t to the 5. So what if it said use the Taylor polynomial t to the 5 for sine of x to approximate sine of 5, then all you have to do is go 1 minus 5 to the third plus 5 to the fifth. I don't know what that is at the top of my head, but that right there is what that is. So what if it then said that it wants you to find what the alternating series remainder would be for that? So once again, we're using t to the 5. So I think we kind of talked about this in the alternating series video, but how the maximum error would be the next one, because remember how I drew this thing? And so the maximum error would be the next one. So this is kind of going back to that and saying that t to the 5 is 1 minus x to the third over 3 factorial plus x to the fifth over 5 factorial. What's the maximum error between this if we plugged in 5? And so let's do it in OVU. What is the maximum error? Like what is the biggest thing we could be off by to what sine of 5 actually equals? Well, that would be the next thing. And that therefore the maximum that we can be off by is 5 to the 7th over 7 factorial. That is the biggest we can be off by. So let's say right now that we want to find the Lagrange error of what we just did. Basically, we're just going to find what the largest remainder would be in for basically what we just did. It's kind of hard to explain. I really almost think that you should just look somewhere else online for this, but basically we're going to write a polynomial, and it's going to be the next one. So Make sure I know how to do this correctly before I teach you something that's completely wrong. Okay, I am back. I'm probably going to try to cut that part out, and if I don't, sorry. But I just need to kind of give myself a little reminder of how to do this. So, if you want to find the LaGrange error, which is kind of basically like the biggest error, but it's a little more specific. I honestly don't know why they make you do this, but and we're right here, we're using t to the 5. So the next term would be x to the 7th over 7 factorial. Basically what we want is we want to find a term in terms of the Taylor format, which would be f to the 7th of c x to the 7th over 7 factorial. And we want to find something that's going to give us the biggest thing. And to do that, we want to maximize the numerator, because you remember, to get the maximum of a number, we want the numerator to get the biggest. So we're going to want to maximize what the f to the 7th, or f 7th derivative, and maximize the x to the 7th. Now, in a problem like this, is going to, a lot of the time, give you a, it's going to give you a restraint. And so here, for this one, we're going to do over 0 to pi over 2. So it will say, find the LaGrange error over 0 to pi over 2, for example. We're going to then find what the, okay, I'm sorry, we're going to want to maximize the parts of this equation. So we want to maximize this part, and we want to maximize this part. So this is centered at x equals 0. So if we had this from 0 to pi over 2 as the interval that we were doing the LaGrange error over, to maximize the f to the 7, well, f to the 7, what is the 7th derivative of sine of x? The first derivative is cosine, second is negative sine, negative cosine, sine, cosine, negative sine. So now we have negative sine, so f of 7 equals negative sine. So what value in here is going to give you the biggest number? But we're taking this in terms of an absolute value, because as we did before with that ratio test, it was an absolute value less than 1. So we're going to take this absolute value. So therefore it's just the farthest one from 0. And if we put in 0 for this, you would get 0. If you put in pi over 2, you would get negative 1, but once again we're absolutely valuing it, so it would be negative 1. So therefore it's max when x equals pi over 2. Then for this x to the 7th part, what's going to be bigger? 0 to the 7th or pi over 2 to the 7th? That's also going to be pi over 2. So that means that the LaGrange error is going to be f of 7 to the pi over 2, because we said that's what's going to be max when that happens, times pi over 2 to the 7th over 7 factorial. And this is going to be, well, negative 1. But the absolute value of this would be 1. So the answer, what is the LaGrange error for this, is going to be pi over 2 to the 7th over 7 factorial, because we want to maximize what is the maximum error, and I hope that made sense.